going to start with ionic solutions. Which is an ionic compound dissolved in water. There are two types of ionic solutions. There are electrolytes and weak electrolytes. It's one or the other. An electrolyte, by definition, is an ionic solution that conducts electricity. So, when the ionic solution breaks apart into positive and negative ions, those free ions give it the ability to conduct electricity. And that's why they call Gatorade an electrolyte, because it has salt, sodium chloride, and potassium chloride. And when we sweat, we lose those, and our body needs to replace them because body functions require ions. That's all I'm going to go into. I am not an anatomy teacher. But electrolytes are ionic solutions that have broken apart into positive and negative ions, and they have the ability to conduct a current, an electric current. There are two types of electrolytes, just regular electrolytes, sometimes called strong electrolytes. This is 100% ionization in water. The whole entire compound that you put in water breaks down into positives and negatives. That's a strong electrolyte. If you put solid sodium chloride in water, 100% of it breaks down into sodium ions and chloride ions. The more ions you have, the more electrolytic it is. Does that make sense? Jonathan?
It's like when you boil off water, are they bonding back together?
They're attaching back together. Yep. Okay, a weak electrolyte has less than 100% ionization in water. And an example of this is acetic acid. And pay attention to this double arrow. Make sure you write down. We're going to talk about what that means in a second. So a weak electrolyte, like this acetic acid, this is vinegar, you put that in water and not all of it dissociates. Only part of it dissociates. It partially breaks apart. But some of it stays together. If it doesn't completely dissociate, you don't get as many ions, and it's not as strong of an electrolyte. It only partially dissociates. This double arrow is the chemistry symbol for equilibrium. We'll talk a lot more about equilibrium after winter break. There's a whole unit on equilibrium. But for now, you just need to know that this arrow means when the reaction is done, you have this, this, and this. All three of those things are sitting in the beaker together. As opposed to this, where when the reaction is done, you have this, and this is gone. This arrow means completely to the right. This double arrow means some of this and some of this. And like I said, we'll talk way more about that later. Questions so far?
So if you get that sample to be completely what is on right, it's a strong electrolyte?
Yes, but you can't.
Okay.
The last type is not an ionic solution, but it's a non-electrolyte. It dissolves, but does not ionize. An example is ethanol or ethanoic acid. When you put ethanol in water, it breaks apart, but it just makes smaller ethanol molecules. It just gets smaller and smaller. They're still completely ethanol. There are no ions at all. Same thing happens when you put sugar in a drink, like sugar in coffee. You don't get sugar ions. There's no ions there. It's just big sugar particles turn into really tiny sugar particles. And that's what dissolving is for non-electrolytes. You see the difference?
So if you like
ions, no ions. Sorry, Max.
if you gave enough time, would it like form back, like all of it is separated, or would it stay separated?
Like sugar? This is confusing, but sugar, yes. So say I dissolve sugar in my coffee and I let it sit for 3 weeks. Eventually the water would dissolve or would evaporate, and then you'd have solid sugar sitting on the bottom. Same thing with salt though.
I've been lied to in a lot of classes.
Questions? Okay, the last thing I'm going to talk about is precipitation, where you take those ionic solutions that we were talking about and you mix them together. So in this one, I'm going to rewrite this so you can see it. We have silver nitrate solution, which is a strong electrolyte. So it completely dissociated. So this was originally this. And it dissolved in water to make that. You mix that with potassium bromide, which is also a strong electrolyte. Originally this. Ionic solution, ionic solution. Strong electrolyte, strong electrolyte. You mix those two together into one container. And if any two of those ions, a positive and a negative, can come together and make something that is not able to dissolve at all, we call that a precipitate. A solid precipitate. In this case, the silver attaches to the bromine to make solid silver bromide, and the potassium and the nitrate do nothing. They just hang out. Because those are a strong electrolyte. They are always soluble whenever they're in solution. We'll talk more about the rules later. This solid is called a precipitate. When you mix two liquids together and form a solid, that's a precipitate. And these two are called spectator ions. Where do you hear about spectators?
Stadium.
Sports and stadiums. When you are a spectator at a football game, that means you do not participate. When you are a spectator ion, it means you do not precipitate. Okay? If we write this whole thing only showing the ions that precipitate, because the spectators spectate, it's called a net ionic equation. Net ionic equations only include the ions that make the precipitate. Questions? Comments? Concerns?
So the net ionic equation you just took out, it's just the precipitants.
Yep, the spectator ions get left out.
Okay.
Well,
Okay.
we have to memorize like what ions are strong electrolytes and what aren't.
Yeah, but it's very simple. We'll talk about it later. Okay, reminder. I'm going to put this on the video. Video people, reminder. Tomorrow, during your class period, and every day we're at home, during your class period, you have to take the quiz over the video. So you'll watch the video, take the quiz. Every day that you're home. Any remote learning days. Okay?